Today let's finish chapter 5. So last time we learned 3 different types of loops. Okay, we learned the while loop, we learned the for loop, and we also learned let me open the chat. What? Yeah, do while loop. Yeah, the do while loop. So I explain one example about the while loop, right? Because we were running out of time, so we went through the for loop and the do while loop quickly. The analysis will be very similar, right? So when you analyze the loop, how the loop is running, you have to follow, right, the method, right? I used last time, right? I used last time here. Okay, last time here. Because we run quickly for this, let's spend 10 minutes to 15 minutes on this on the for loop example and do while loop example to explain how the loop structure works. Okay, works. So this is the for loop. Okay, this is a for loop. Let me copy the. Sorry. I have to do this. So this is a for loop. Okay, this is a for loop. Okay, this is a for loop. So I copied this example from the slides. Okay, so let's see what is the value of the count variable when we finish the for loop. Okay, so if you are new in computer programming, so this concept is not that clear. Okay, you need to run this for loop by yourself. Okay, for loop by yourself. So as we have learned last time, so in the for loop we have 3 components. The first component, this one, is the initialization. So the initial value of the count. Here, so before we start anything in the for loop, so the initial value count equals 1. Okay, that is the first step, count equals 1. So the second step is count is less or equal than 5. It is a condition. It is the Boolean expression. So the last part is the update expression. It means when the condition is true, when we finish all the statements inside here, so how we update the count variable, we have initialization, we also have expression, condition. So the last component is the update expression, okay, the update expression. So let's analyze this problem with the logic we have last time, okay, last time. So I use a table we created last time to analyze this example, okay? I delete all these things, okay? So in the first iteration, so for initialization, right? Count equals what? Count equals 1. That's given in the initial condition, right? Initial condition. So because count equals 1, so the expression, right? The next step. So let's write it initialization. Okay, I only have, I think I need this. Count equals. Okay, count equals 1. Okay, count equals 1. So the expression, I follow the flow chart for the for loop we learned last time. Okay, for the expression is count is less or equal than 5. Okay, that is the expression given in the for loop condition. So count is less or equal than 5, right? The value of count is 1, so it is. So 1 is less or equal than 5. Okay, 1 is less or equal than 5. So it is true. Okay, it is true. So we go inside the for loop, right? The for loop, and execute the statements. Okay, we execute these statements. We execute these statements. So after we finish, so we update, right? We update. The update is count plus equals 3, right? The update is count plus equals 3. Okay, count plus equals 3. Count plus equals 3. So count plus equals 3 is equivalent to count equals plus 3. Okay, I got some noise. Let's see what gave me the noise. Okay, audio muted. Okay. So count equals count plus 3. Basically, it means count after update, right? After update. So we have count equals 1 plus 3 equals 4. Okay, equals 4. Okay. So you see the 3 components are initialization, right? And expression. Then the update. Okay, the update. The 3 different components. So when we have the update, right? So for iteration 2, the int variable count equals 4 because in the end of iteration 1, right? In the end of iteration 1, count equals 4. So in the beginning of iteration 2, count equals 4. Okay, count equals 4. Okay, count equals 4. So in the beginning of the second iteration, count equals 4. Then we want to check the expression, right? We check the expression. So the expression count is less equal than 5. So because count equals 4, 4 is less or equal than 5. So the condition is true. Okay, the condition is true. Okay, it is true. So similarly, we go inside. Okay, we go inside. We go inside. Go inside. Okay, we go inside the for loop, right? The loop, and execute the statements. Okay, after this, we still need to update, right? We have update. Okay, update. So for update, count plus equals 3. It is equivalent to count equals count plus 3. Count now equals 4. 4 plus 3, it is 7, right? It is 7, okay? So it is after update. So we have count equals 7. Okay, we have count equals 7. So then we move on to next iteration. So count now equals 7, right? Count now equals 7. So count equals 7. So we need to test the expression, right? Expression. Okay, test expression. Count is less or equal than 5. So now we need to test if 7 is less or equal than 5. Now the condition is false. Okay, it is false. Okay, it is false. So because it is false, so we will not go inside the for loop. Instead, we jump over the for loop structure. Okay, structure. Okay, we jump over the for loop structure. You see that in this example, right? In the slide, in this example, basically we will run 2 iterations. Okay, we will have 2 iterations. So in iteration number 3, so while C# tries to test the expression, so the expression will return false value. It means that there is no the third iteration. Okay, there are only 2 iterations. Okay, so when you analyze the loop structure, for example, a for loop, you need to do this kind of details. Okay, show me all details. Okay, especially in the exam. Okay, so the point is, I want to make sure that you understand how for loop will work. For example, you have initialization, you have expression, you have update. How these components, okay, will work for loop, okay, for loop. So this is the for loop example, okay, for loop example. Let's go. We'll go quickly, okay. So the next one, it is do while loop, okay. Remember, for the while loop, it is a pre-test loop. It means we will test the condition first, then consider based on the result. We will consider if we are going to run the loop or we skip all the loop. For the do while loop, it is a post-test loop. It means we will run the statements no matter what is expression. After we finish, we test the expression. If the expression is false, we're done for the loop. Otherwise, we'll go back to run the statements again. In other words, at least we will run the statements inside the do while loop at least once. At least once. So let's see. So let's see this example. Okay, this is the example. Okay, it's a do while loop example. Okay. We have x equals 2, y equals 4, x equals 2, y equals 4. Okay, and we have this code. Okay, this is the code we have. So for the do while loop, okay, for the do while loop, we still copy this table. Okay, we don't have this kind of thing, we delete it. So for the do while loop, right, no matter what is the condition, we will execute the statements inside the loop structure at first, in the beginning. Then we test the condition, okay? So it means, so x equals 2, y equals 4, before we do anything, right? Before we do anything, in the do while loop, okay? That's the beginning. The initial value of x and y, which are given 2 and 4. So then because we are going to execute the 2 statements inside, right? Inside the loop structure before we test the condition, okay? So we have x plus plus, okay? So x plus plus is equivalent to okay, it is, let me see if I can put a symbol. So it is equivalent to x equals x plus y, right? Increase x by 1. We learned this last time, okay? X equals x plus 1. So x equals 3, okay, after this statement. Similarly, we have y plus plus, right? Which is equivalent to y equals y plus 1, okay? Y equals y plus 1. So it means y equals 5, okay? Y equals 5, okay? After we finish these 2 statements, so we are going to test the expression, which is x is less or equal than 3, right? That is the given expression. So the x value is what? It is 3, right? It is 3 now. So basically, we have 4. No, sorry. We have 3 is less or equal than 3. We want to see that if it is true that 3 is less or equal than 3. So it is true. No problem. It is true. So we will go back, right, to do the loop again. Okay. So we will go back. We'll go to do the loop again. Okay, loop again, which means we go back to the do part and execute all the statements inside the loop structure. Okay, so now we have x equals 3, y equals 5. Okay, y equals 5. So we have, because we will go to do the loop again, so we have iteration number 2. For iteration number 2, so before we do anything, right? So the value of x equals 3, y equals 5. Okay, y equals 5. So we can have, x plus plus, right? I copy these 2 lines here. X plus plus, it is equivalent x equals x plus 1, because now x equals 3, now x equals 4, right? Y is 5, so y equals 5 plus 1, it is 6. Okay, it is 6. So now we finish the 2 statements inside the do loop, or the loop part, right? We are going to test the condition. So the condition is x is less or equal than 3. Okay, x is less or equal than 3. So the value of x is 4 now, right? It is 4. So for 4 is less or equal than 3, it is false. It is not true, right? So we will skip the do while loop, okay? Because the condition is false. It is false, we will not go back for another loop, okay? So after this loop, x equals 4, y equals 6, okay? Y equals 6. So because we will skip the do while loop, no iteration number 3, okay? We have no iteration number 3. So you see that in this do while loop example, so we only have the condition to be true once. In the first loop, we check the condition, right? The condition is true. In the second loop, the condition is false. It is true only once, right? However, we have 2 iterations. Okay, for the do while loop, right? At least we will execute the loop at least once. Okay, that is the key idea. Okay. So now we have learned examples for the while loop, for loop, do while loop. Okay. If you have some code experience, this is not new because these 3 different loop structures exist in all advanced programming languages. It is not new. However, if you are new in computer programming, okay, and you really want to dig into business analytics, you want to learn algorithms, this is the most frequently used structure when you want to process data. Why? Because when you process data, right, each data entry needs to be repeated, be processed with same code, right? With similar code. For example, I need to extract name of the student. It means I load the record of the student, extract his name, put in a data set, then move on to next student record, right? Same process will be applied to each student. It's an iteration. It's a loop. Question?
So in BA, the most common structure is the for structure.
Mm-hmm. Which one?
The for structure you're saying is the most common.
I mean, all common, but for is the most frequently used because most of the time you have an idea how many loops are there. For example, I have 40 students, right? in my intuition, there will be 40 loops, 40 iterations. So I will design a counter from 1 to 40, right? That's enough. However, occasionally, you may have different conditions, right? For example, I want to count the number of students, right, who got C. No, it's not a good example. It's like this. It's like I want to do something, but I have no idea how many iterations are there. But I have stopping criteria, right? For example, in computation, sometimes, right? Sometimes you would like to see that I want my algorithm to converge to some criteria, no matter how many iterations are there. For example, it can iterate 50 times, 70 times, 80 times, but I want my error is small enough. Okay, in this case, right? In this case, the condition will be the while loop. The condition is my error is less than threshold, I jump out. Otherwise, I stay inside, right? Because you have no idea how many iterations will be there. Okay, this is one case in which you may want to use while. But to process the data, you usually will use for loop because you know how many iterations are there. Okay, okay. So this is the for loop, do while loop. Okay. So if you are not fully very clear about these examples, so I have written down all the details in the notes, right, in the lecture. So please do similar thing by yourself. Okay, analyze the loop step by step. Okay, after you fully understand these examples, I believe you have a better idea how it works. Okay, if you are not fully clear about the 3 different loop structures. Okay, loop structures. So now let's move on to remaining part of chapter 5. Okay, so we have learned 3 different types of loops. Now we need to learn something how to use them. How to use that in this course. The next topic is using files for data storage. What is that? Remember, in the second assignment, if you have started, right? Have you started the second assignment? Assume you have started because the due date is in 2 days. Okay, assume you have started. So for this topic, remember the output of assignment 2 is to summarize all the information in a message, right? You put the semester information, you put the course information, you put everything, right, in one message. Okay, it means when we click save, right, a message pop up, you click OK, it's gone, right? It's gone. However, now we want to learn something. When we have summarized all the results, we want to save the results as a local file in your laptop. In this course, we make it simple. We want to save all the results as what? As a TXT file. Okay? It means, so the results, all the data are saved on your hard drive. In the future, if you need to check the results or you want to use the results again, right? You can find it. It is not a message box, right? For a message box, so you see the message, you click OK, it's gone. Okay, it is gone. However, for data storage, we do want to save all the results as a local file. That is idea, okay? So one program needs to save data for later use. It writes the data to a file from which the data can later be read. For example, you have use some algorithm to analyze data, right? You want to show the results to your boss. This is my results, right? So you need to save, right, all the results to some file and show your boss the file. Okay, those are my results. So there are 3 steps to the process. So we have opened the file. It means we want to open a local TXT file. So we want to process a file. It means that we want to write our results to the file. Then we close the file. Okay, we open, write, then close. This is a process. In general, there are two types of files to process. We have TXT files. So it contains data that has been encoded as text using a schema such as Unicode. Such data can be viewed in a text editor. It means in Windows, right? So you open the TXT file, you see the results. Okay, you see the results. So the second type is binary files. So the binary files contain data that has not been converted to text. You cannot view the contents of binary files with a text editor. It is 010 data, which can be understood by the machine, but we cannot understand it. Okay. So in this chapter, in this course, we will only cover working with TXT, text files. Okay. In the future, when you learn other languages, you will learn how I can save my data or my results to an Excel file. So the logic is similar, okay? So we will, in this course, we only cover TXT file, okay? TXT file. So the first thing is file access methods. So programming languages typically provide two different ways to access data stored in a file: sequential access and direct access. So when you work with a sequential access file, you access data from the beginning of the file to the end of the file. So it is similar to the way music is listened to on a cassette, right, tape. You listen to the songs in a specific sequence. It isn't practical to jump around to listen to songs out of sequence. So basically, you need to understand when we access a file, we access all its content in a sequential pattern. Okay, for example, if you open a TXT file, there are multiple lines. Okay, we will start from line number 1, then line number 2. Okay, one by one. So when you work with a direct access file, however, you can easily jump directly to any data item in the file. So it is similar to listening to music on a CD or MP3 player. Okay, this chapter only covers working with sequential access. So because this course is a beginning coding class, okay, so we do not want to make it too abstract. You see, it is already quite different from other courses you have taken. Okay, to be honest, there are no case study, right? There are no fun story. Okay, most things are knowledge, methods, controls, right? Techniques, sometimes simple mathematics, right? All techniques. It's not a fun class, right? Because we consider it is a beginning coding class, right? We do not want to make it too complicated. That is the intuition of the course. Okay, intuition of the course. You see that's why for most topic, we try to cover a basic concept. Okay, for example, we only consider TXT file. That's it. Okay, we will not do Excel file. We only do TXT file because you learn this TXT file, you know how you process data. You save and load data from your computer. Okay. Similarly, this chapter only cover working with sequential access. Okay, it means when we open a TXT file, so we will access the file from line number 1, then line number 2, then line number 3, one line by one line. Okay, from the beginning to the end. Okay, from the beginning to the end. The second component is file names. Each computer operating system has rules for naming files. Many operating systems, including Microsoft Windows, support the use of file name extensions, which are short sequences of characters that appear at the end of the file name and are preceded by a period dot. It's like .txt file. You will see that it's a text file. It is a text file. Specific file name extensions are used for specific types of files, like .doc or .docx. These are Word files. Okay, these are Word files. So in this chapter, we will read and write txt file, which is .txt file. Okay, .txt file. That is the target of this chapter. I want to learn the file objects. So file object is an object that is associated with a specific file and provide a way for the program to work with the file. So a variable is linked to the file object to reference it. The .NET framework provides two classes to create file objects through the system.io namespace. Okay, so what we have stream writer for writing data to a txt file. We have stream reader for reading data from a txt file. You need to write the following at the top of your program using system.io. So remember this, because when we need to use this read and write files to a txt file, in the very beginning of your code, you need using system.io. If you don't have that line, C# will give you an error message. Like stream writer, stream reader is not a valid method. Okay, or not a valid method. Okay. So this is the file objects. So what is that? Basically, we want to create a variable which can be used to point to the txt file. Okay, that is the file objects. So now we learn how we write data to a file. Okay, these are the procedure. This is the format. First, we need to start with creating a stream writer object, which is this. We use the keyword stream writer, then we put a name, object name of the object output file. Okay, output file. So one of the file methods is then used to open the file to which you will be writing data. First, we create a stream writer object. For step number 2, we will point out this output file stream writer object will be associated to course.txt. Okay, you see that here we use file.createText. It means we will create a txt file from nothing. We will create a txt file, and the name of the file is courses.txt. Courses.txt. After we create this file, the write or write line methods can then be used to write items to data into the file, like output file dot write line. We have English composition. It means when we write we use this statement, English composition will be written in the file courses.txt. Okay? If we have another course, right, we can do output, which is French. We can do output file, write line, French, right? Then we have another statement to write another line to the courses.txt file. When we finish everything, we have written everything in the file, we will do output file close. Okay, this is the standard procedure. Okay, standard procedure to write files to a txt file. Step number 1, we create a stream writer object. Step number 2, we associate the created object to a file. In this case, we create an empty txt file with the name courses.txt. Okay. Step number 3, we do English composition. English composition. So when we finish all the inputs, all the output to the target file, so step number 4, we use close method to close this txt file. Okay, to close this txt file. The standard 4-step procedure. Okay, for how we can write content to our local txt file. to a local txt file. So here is one specific example. Step number 1, right? We create a stream writer output file, okay? The object is output file. Step number 2, we associate the object output file to the new created file courses.txt. Step number 3, we write 4 courses: Intro to Computer Science, English Composition, Calculus 1, Music Appreciation. We have 4 different courses. When we finish all the content output, right, we perform step number 4, which is to close the file. Okay, typically there are 4 steps how we write content to our local file. Okay, to a local file. So the write line method writes an item of data to the output file and then writes a new line character which specifies the end of a line and moves the cursor to the beginning of next line of the file. The write method writes an item to a file without adding a new line character. It is write line, one line content, move on to next line, right? Write method, write this line, but still stay in the same line. Okay, this is the difference between the write line method and write method. Okay, for example, in this example, we have the write line method. It means that, so when you finish the output, right? When we finish the output, so the final txt file will look like this. Okay. Okay, we have 4 lines. Each line is 1 course. Okay, each line is 1 course. Okay, if we use write line method for these 4 different courses, that will be a final output file. However, if we put write method, okay, these 4 courses will be put in the same line. Okay, because for the write method, so we will stay in the same line without changing to a new line. Okay, without to a new line. Okay. So this is a sample code. We have a save button click, right? So we have try catch method to prevent some exception. So inside the try part, we have, so declare a stream writer object. Create a new txt file, courses.txt, associate the file to output file object. Then we have 4 different outputs, right, to the txt file like this, 4 different lines. When we're done, close the file. Okay, close the file. Remember, when you finish, you need to close the file. In previous semesters, there were some students who found there were some errors in their code. For example, their output file was not correct. Most of the time, it is because you forget to write this close line. Okay, last line, output file dot close. Okay, to close the file. So this is sample code in program context. Okay, so we have this example. Assume we have defined a stream writer output file. Write the statement to create a txt file, courses.txt, and write the course physics in it. Okay, I ask you to only write 1 course physics in this example. So because the stream writer object output file has been created, so it means the first step is given. Your answer should start from the second step. Okay, we have output file equals file.create text courses.txt. Second line, output file.write line physics. When you're done, the last line will be output file.close. Okay. So in the exam, if this is a problem in the exam, if you forget the last line, okay, it is still correct. But in practice, you need to remember the last line has to be there. Otherwise, your output file will be incorrect. Okay, the last line has to be there. to close a file, okay, to close a file. So the next question is, we save the file to a local, so somewhere on your laptop. Where is it? Where is it? So the default location, okay, the default location for a file. So it is there, okay? For example, this is my project, okay? This is my project. So in your project folder, you have a SLN file and another folder, right? You go to the folder, there are a bunch of different folders and files, right? Inside this main folder, okay? You go to bin, okay? Bin, and you go to debug. So the txt file is inside this folder, okay? This is the default location of the file. So it is in the default, right? The main project folder, bin folder, debug folder is inside, okay? In this folder. It means that when you create the courses.txt file, and you have written some courses to this txt file, right? So it is there. It is inside this main project folder, bin debug folder, okay? It's there. So it's here, right? You have project, right? You have bin and debug, okay, debug. So you can also specify a location for an output file. So we do not require you to do this in your project, okay? So if you want to create or open a file in a different location than the default, you can specify a path as well as a file name in the method argument. This tells C# the specific location that should be used for the file. So we have prefix path stream with @ character, okay? @ character, for example. We declare a stream writer object output file, but the file is in a different place. It's not in the default location. In this case, we are going to file.create text @ it is in C drive, backup folder, notes.txt. Okay, you can also create such a txt file in a different location. Okay, a different location. However, in this course, we will typically utilize the default location for our files. So in the next 2 assignments, in the next 3 labs, when we need to use this file, they are in the default location. Okay, they are in the default location. So we have 2 different methods. The first one is create text. The second one is append text. So what's the difference? So create text is to start from scratch, start from nothing. We create an empty file and work on it. That is create txt file, okay, txt method. Another one is append txt. What is that? For example, we have put 4 courses in the txt file. However, we want to add another course except the 4. It means we want to keep the existing 4, right? But we want to add another one, the 5th one. In this case, if you create a new txt file, you need to start from nothing, scratch, right? But since we already have the file with the 4 courses, we can append text. It means we will use an existing txt file, keep all its content, and add additional content to the txt file. Okay, that is append txt. We access an existing txt file, open it, add additional content, then close it. Okay, we have 2 different things. Okay, 2 different things. So while you work on your project, assignment and labs, be careful which one is the required method. Sometimes you need to create a new txt file. Sometimes you need put additional content to an existing txt file, right? So these are the 2 different methods. Okay, 2 different methods. So now we finish how to write data to a TXT file. Then the next question is, so I have some data in my hard drive. I want to load the data in C# and work on it. How to do that? So it is, we want to read data from a file. Okay, read the data from file. So the procedure is very similar as how we can write data. Step number one, we create a stream reader object. Okay, stream reader input file. Okay, that's the first step. Then step number two, we need to open the TXT file on your hard drive. The method is file.openTXT method. Okay, you see here example is we will open the TXT file student.txt. Okay, then we want to associate the stream reader object input file to the TXT file. We open an existing TXT file. Then we want to read line. You see, this time we have student name equals input file dot read line. We have read line method. Okay. So we have read line method. It means that we will read one line. Okay, read one line in the TXT file. After all data is read, the file is closed, like input file dot close. Okay, it means we have a similar procedure to deal with how to read data from a file. Step number one, we create a stream reader object. Stream reader object. Step number two, we open an existing TXT file and associate this file to the object input file. Step number three, we want to read, right? Read data from the file. Step number two, we have input file dot close. Okay. So while you have these four steps, you may have a question. So for step number three here, we have read line, right? We have read line. So does C# read all the lines? For example, I have 4 courses. But will C# read all 4 lines? Or it will just read one line, right? Because read line seems it is reasonable to read one line. For example, the first course, Intro to Calculus. But it may not read the other 3 lines. Okay? So that's a question we will solve. So for this line, it will read only one line. Okay, but we will learn how we can use a loop structure to read all the lines in the TXT file. Okay, all the lines in the TXT file. So the trick is we want to use a loop. Okay, want to use a loop. So stream reader objects have an end of stream Boolean property that signals if the end of the file has been reached. You can write a loop to read in the lines of a file that detects when the end of the file has been reached, like this one. So while if input.end of stream is false, it means we have not reached the end of the file. Keep reading, okay? If input file end of stream is true, it means we have reached the end of the file. There are no more additional lines. We have done all the reading. Then this variable end of stream will be true, right? True does not equal to false. The condition is false, right? So we jump out the while loop. You see, this is one example. We have no idea, right? How many loops are there? We will stop when we reach the end of the file. For example, if the file contains 4 lines, 4 courses, it means the loop will run 4 iterations, right? If there are 10 courses in the TXT file, there will be 10 iterations there, okay? It means we have no idea how many loops are there. It depends on the actual file. So in this case, we use a while loop. Okay, we use a while loop. So this is a tricky part. Okay, this is a tricky part. So this is a sample. This is a sample. You see. So we declare stream reader input file. We try cross list box dot item clear. We clear all the items in the list box. We open the txt file courses.txt and associate the file to the input file. Then we use a while loop. You see, in the while loop, in each iteration, we will read one line, right? Then we use the cross list box.items.add method to add this readed line, red line, cross, right, to the list box. Okay? So if we have not reached the end of the file, we keep reading. Otherwise, we jump over the while loop, close the file. Okay, and close the file. So using the while loop is the tricky part to read all the entries in the txt file. Okay, in the txt file. So here are something you need to learn when you work on your project. The first one is running totals. A loop can allow a program to keep a running total while evaluating data, which is a sum of numbers that accumulates with each iteration of a loop. The variable used to keep track of the running total is called accumulator. Common use include keeping a running total of user inputs during a program run, or totaling a series of values read in from an input file. Okay. So for example, this is example to calculate all the numbers from the file. Okay, you see that we first declare a decimal variable sales, and decimal total is 0. Okay, we declare stream reader input file. We open the sales.txt file and associate the file to the input file. Then we use a while loop to see if we have reached the end of the file, right? So we read a line. You see, we read a line, right? But remember, when we read a line from the file, it is a string. It is not a number. So we use decimal.parse method to transform the string to a number. Then assign the number to sales. Now we have total plus equals sales. It means total equals total plus sales, right? So when we finish, basically, we read all the numbers in the file and sum up. Right? When we finish, remember we close the file. Okay, we close the file. So then we output the total to the total label. Okay, total label. So this is an example how we calculate the running total. So we finish the read and write, how we can read and write txt files in C#. The next topic is the open file dialog and save file dialog controls. The open file dialog and the save file dialog controls allow your application to display standard Windows dialog boxes for opening and saving files. The open file dialog control displays a standard Windows open dialog box, while the save file dialog control display a standard Windows save as dialog box. Okay, and we want to display an open dialog box. When adding an open file dialog control to a form, it does not appear on the form. It's here, right? Similar as a tooltip. Okay, it is not on the form. It is below the form. So the default name will be open file dialog 1, which you should change. Remember, when you add one control on your project, the first step is to rename the control. In code, you can display an open dialog box by calling the show dialog method. It is open file.show dialog method. So that window will pop up. So when we open a dialog, how we detect the user selection, so we detect user open file or cancel. Okay. So if the open button is clicked, dialog result.ok is returned. Okay, we have OK, return the value. If the cancel button is clicked, dialog result.cancel is returned. We use these two different returns to check which value is returned, okay? For example, in this example, if open file show dialog, OK is returned, we do something. Else means if we cancel clicked, we do something else, okay? We do something else. So the file name property, when a file is selected with an open dialog box, the path and file name are stored in the control file name property. For example, we still do string reader input file. If so, the user click a file and click OK. A file is selected and the user click OK, not cancel button, OK button. In this case, we can get the location, right, the path of the file name of the file to in the open text property, input file. Okay, input file. We can get the path and file name from the file name property. Okay. While we learn this, remember in the previous step, right? We learned how to read a file. In this step, we want to build an interface. How the user can figure out a figure for us to read, right? The user find a file on his or her laptop, click it, click OK, then we will read or write on that file. Okay, so this is the pre-step for what we have learned, how to write and read data. Okay, how we write and read data. So in this example, if the selection is not open or OK, so we have a message, no file was selected, no file was selected. So we also have the initial directory property. You can specify a directory to be initially displayed in a dialog box with initial directory property. It's like this, right? So when we click the dialog, it will open a default location. So we can set up open file dot initial directory equals C drive data file, a data folder. It means when we click the open dialog, so the location C drive folder data will be opened by default. For example, right? Remember in Word, okay? When you open, you click open file. For example, in my Word, let's see. This is my Word, okay? For example, if I click open, right? So I have a bunch of locations to select, right? I click this PC, right? You can select where to open, right? So in C# we will not have these advanced functions. Instead, you can set up a default location to open for the dialog. Here's the dialog, okay? So displaying a save as dialog box, the save file dialog control has much in common with the open file dialog control, including how it is added to a project, its various properties, how it is added to a project, its various properties, how it is displayed, and how the user selection is identified. For example, for the save thing, if the user click OK, it means is user clicks save button, we will append text, right? So save file dot file name, we will save the thing, put additional content in the corresponding file. Otherwise, we will do something else. Okay, this is the save dialog, the save dialog. So here is one example. Assume that we have defined a stream reader input file. Write the statement to open the txt file course.txt in the default location. So you do that input file equals file.openText. We have courses.txt, okay, courses.txt. So this is the example. So the next topic is random numbers. Okay, random number is a very important topic in scientific computing, which is not the key topic in this course. Okay, for example, if you take a graduate level course in simulation, okay? So you spend a couple of lectures to learn how to generate random numbers, okay? Random numbers. Why we need that? You may ask, why we need that? Because sometimes in order to test on your results, in order to analyze something, you need to generate some random number. For example, I want some random number which follow normal distribution or uniform distribution. How to do that? In C#, in R, in Python, there are methods, right, to generate random numbers. Okay, random numbers. The .NET framework provides the random class to generate random numbers. To create an object of the random class, we use this random, that's a keyword. RND is the name of the object. It is new random. We generate a new random object, okay? Two commonly used methods of the class are, the first one, it is next, create a random integer number, okay? The second one is next double, create a random floating point number in the range of 0.0 to 1.0, okay? So random.next will give us a random integer number, whole number. But random.next double will give us a random number between 0 and 1, a floating number, okay? So the next method generates a random number in the range of 0 to this 2147, 483, 647. Very large range, okay, very large range. It also allows you to generate a random number in a specific range from 0 to some positive number. You see here we have two examples, and these examples are tricky. For example, the first one. So we have rand for rand, but we assume we have do this. We have done this. We have declared rand to be a random object. Okay, rand to be a random object. So we have rand.next 100. Okay, it means because it is 100, it means we will have a range in 100 data points, but the range of the 100 number is not 1 to 100. It is 0 to 99. Okay, it does not start from number 1. Instead, the first number, the starting number, is number 0. Okay, you have to be very clear. Okay, for example, if we see that rnd.next 100, you need to understand the range is 0 to 99. We will not see the number 100. Instead, we will see a number between 0 and 99 question.
Can you specify the range inside the parentheses, like what 0, 1?
No, you give a number, but you can only, it is 0 to a number. You can use some trick to specify the range, but that's a tricky part, okay? But for this method, so for example, you figure out rand.next 1000, it will be 0 to 999, not 1 to 1000, okay? For that part, you have very clear. Now you may ask, but I'm interested in a number from 1 to 100. I'm not interested in 0 to 99, right? This range, 0 to 99, is different from 1 to 100. So what's the trick? It is we use rand.next 100 plus 1. Because rand.next 100 will give a number from 0 to 99, right? Plus 1 means all number increase by 1. Right? Then by using this trick, okay, we will be able to generate random number from 1 to 100. You may also ask, right? So you may also ask, for example, can I generate a random number from, let's see, 21 to 49? I pick an arbitrary range, okay? A random integer in this range, 21 to 49, okay? At first, let's see how many numbers are in this range, okay? So from 21 to 49, right? From 21 to 49, there are 29 numbers, okay, right? If you count, okay? From 21 to 49, if you count. There are 24, let me use a different term, integers, okay? 21, 22, 23, 24. You count until you get to 49, right? There are 29 integers, right? So if I use metric, I do rand dot next, right? Rand dot next 29. I use this. So what I can get is, so we will get a random number from what? From 0 to 28, right? From 0 to 28, right? Based on the slides here. Okay? So in this range, 21 to 49, there are 29 integers, right? If we use 29.next 29, so we will get a random number from 0 to 28 based on what we have learned here, right? But if we do rand dot next 29 plus 21, what we can get? So if we do this, right, the whole range will be increased by 21, right? Plus 21. So we will get a random number from 21 to 49, right? So which is the target range, okay? Which is the target range. It means, given this rand.next method, we can use this kind of trick to generate a random integer number in any range. Because 21 to 49, that is an arbitrary range I just picked, random range I just picked, right? For any given range, we can generate a random integer number by using rand.next method, okay? This is how we use a trick. This is how we use a trick, okay? So here is one example. Generate a random number, random integer from 3 to 100. From 3 to 100, we have 98 numbers. So we do rand.next 98. Then we increase the range by 3. We get 3 to 100, okay? Which is similar as the example I just explained. Okay? So the next topic is a load event. When running an application, the form is loaded into memory and an event known as a load takes place at once. So for an event handler, double-click the form in the designer. Any code you write inside the load event will execute immediately when the form is launched. Okay? It is this. When you start the form, there is an event. If you want to do something, right? So you need to create the load event. Why we need it? Because in your project, in your assignment, right? When you start the form, some input area, some area need to be initialized. For example, when you read the price, right? We read the price from the file, right? The price for each course need to be updated in a corresponding area, Okay, that part has to be put in the load event. Okay, the load event. Okay. So the load event, another use of the load event handler is to hold code that sets the text property values of controls on the form using class level program constants. You see, that is what I just mentioned. So in the example below, constants were declared at the class level for some prices that need displaying on the form when the program initially runs. Okay, so you need to use something like this in your project, to be honest. So you see that in the very beginning, I have declared the constant flea removal price, nail clipping price, shampoo price, and fur trimming price. I have declared 4 different constants. So when I run my application, I want the corresponding price label to be updated to these different these different constants. According to these different constants. Okay, this is a form 1 load event. It means when you click the run button, when the form starts, right, then the corresponding labels will be updated immediately to the corresponding prices. Okay, to the corresponding prices.